So with any word problem section, we have to remember that it's only going to test the stuff we just did, and one of the big ones is y minus y1 equals slope times x minus x1. Yep, we're bringing that whole thing back. I told you it's going to be here for a while. The other thing is that we're going to model this. I want to do one problem per page. So I'm going to do this on graph paper. I'm going to pause the video and switch this over. So I have this on a separate page now, and I need to analyze this. So Mr. LaFleur pays $130 to rent a car for 1 week. Then he pays $5 for every 100 miles that he drives. And we want an equation to show the relationship between the total cost of renting the car and the number of miles that are driven. So if I'm going to show the relationship, kind of like a relation between the total cost of renting the car and the number of miles that are driven, I need to figure out which one of them is my independent and which one of them is my dependent variable, or manipulated or responding. Which one am I plugging in? Well, I want to plug in my x, which I want it to be the number of miles driven. So that kind of leads me to think, okay, so we're going to say let x equal number of miles driven. And then we're going to let y equal total cost of renting a car. Now I'm doing this, and again, you could do this with x and y reversed, but it's a far better one if we kind of figure out number of miles driven is what we don't know, what we want to plug in, and then total cost of renting the car is what we want to get out. Again, I'm going to make the x be the manipulated and the y be the responding. So what am I changing and what's responding because of it? Cost typically responds because of it. So it's $130 to rent a car for 1 week. That right there is kind of like a flat cost. And the $5 for every 100 miles that are driven, that's a rate. So when I say number of miles driven, I actually want to kind of modify that. I'm going to put a single line through that. I'm going to say number of 100 miles driven, because the rate that's given is in terms of 100 miles, and this will actually be an easier equation if I do that. So I have a flat cost, a cost that I'm charged no matter what, and then I have a rate for every 100 miles that I drive. So you could say that the total cost starts off with $130, but we're going to add to that $5 for every 100 miles that I drive, and that's going to be equal to cost. And if I kind of change that, just kind of simplify that a little bit, I have y is equal to 5x plus 130. Now, this is slope-intercept form. So what I can say is y is equal to slope times x plus my y-intercept occurs when x is 0, so that's like a flat rate. This is another way of thinking about slope-intercept form. Then it wants me to draw a graph. And like most graphs that we're going to do, this is going to be a one-quadrant graph, meaning everything from x to y is positive, so I'm only going to draw the first quadrant. Furthermore, I'm going to look at what my units of x and y are, and I want to label things. So x is number of 100 miles driven, and y is total cost, and that's in dollars. So that's y, and then that's x. Now, if I do a simple t-chart of what's happening, and I put in x and y, when x is 0, y is 130. When x is 1, y is 135. When x is 2, y is 140. So what I'm going to do is sort of set this graph up so it can work better for us. This will be 100 miles driven. This will be 2, 3, 4, 5, etc. And then we're going to start right here, and I'm going to make that be 130, this be 135, this be 140, and my dollar amounts are going up by $5. How can I do that? Because clearly this is not the same distance as this. Well, what I'm going to do is I'm actually going to do something that we can only do on special occasions, and this is one of them. I'm going to put a break line in there, which means that even though that this point represents 0, 0, the break line means we're going to skip until we actually have something. And that break line technically applies for the whole graph, but we only show it there on the y-axis. So I'm going to plot my ordered pairs. 0, 130 we just plotted, 1, 135, 2, 140, and you can figure out that the pattern's going to keep going because my slope is the same. You may ask yourself, what is my slope here? It's not 1 over 1 because my units on y are different than my units on x. This is actually a slope of up 5 over 1, so it is a slope of 5. Then I'm just going to take my ray and I'm going to continue that on. So that was a little small, but I do want these one per page because I don't want you cramming these into a corner, and some of you tend to do that. So we're going to move on to number 2. Number 2 says, an author sells his latest book to a publisher for $5,000 plus $3,000 for every book that's sold. Let's identify which one's the rate. Here's the rate. And here's the base cost, or what I can call the initial or the flat rate. That's going to be like my y-intercept. And this one here is going to be like a slope. So if I kind of put those together, we can actually come up with the equation of the line. But now I need to figure out what my variables are, and we have to define variables. Write an equation and draw a graph which shows the relationship between the author's income and the number of books that are sold. So what's the manipulated and what's the responding going to be? Well, let's manipulate the number of books that the author sells, and let's respond with the author's income. How many do I sell? Then how much money do I make? We're going to write let x equal the number of 1,000 books sold, because it says every 1,000 books sold, and that just makes this easier. And then we're going to say let y equal to the total income. So if I go to an equation, I want to do y is equal to $300 for every 1,000 books sold, so 300 times x, which is the number of 1,000 books sold, plus the $5,000 he got as kind of a flat rate or an initial or whatever, a finder's fee or something. So now let's graph it. We can turn the grid line back on, and like before, we're going to do a first quadrant graph. I'm going to err on side of making this bigger. And then I'm going to do just a simple t-chart off here just to make sure we got the first few values going. When x is 0, y is 1. Y is 5,000. When x is 1, and I plug that in, I get 300 plus 5,000, so 5,300. You can keep the pattern going to 5,600 and so on, adding 300 every time. Let's go back over to here. We're going to label our axes. X is number of 1,000 books sold, and y is total income. My first point was 0, 5,000. I'm just going to stick that here, and we're going to label that 5,000, and that's 0 books sold. I'm going to stick my little break line in there again because I'm skipping from 0 to 5,000, but my next step is going to be 5,300, 5,600, 5,900, 6,200. Let's just keep this going up. 65, 68, and 7,100. And then the number of 1,000 books are 1, 2, 3, 4, 5, 6, 7. And we just want to make sure we fill the graph as best we can. So let's just kind of keep these going up until I run out of space. That could be 8. And that gives us plenty of information on this graph. So we're going to connect. Oops, I didn't draw that graph right. All of these need to shift up 1. There we go, 1, 5,300, and so forth. And so now it's correct. And that looks good. I could say, what if I were to sell 7 books? And you would look up and say, then you would make $7,100, and so forth. Okay, pause this. Like before, I'm using a lot of space. It wants me to write an equation that relates the total cost of going to an amusement park to the number of rides. This dates back to when they would charge you a small amount to enter a park, but then they charge you a cost per ride. So if I say, we're going to start with y, let y equal the total cost. And then we'll say let x equal the thing that we can control, which is the number of rides. If I have that, then part A, writing an equation to relate them, means I'm going to do my 35 cents per ride, so y is equal to 35 cents. Well, we want our total cost in dollars, so I'm going to put it as 0.35 times x, and then plus the $8 to enter the park. So that is the first equation. And then it says, for part B, how much would someone spend at the park who goes on 9 rides? Well, 9 rides, that's an x, so I want to substitute x equals 9. Y is equal to 0.35 times 9 plus 8, which is 3.15 plus 8, or $11.15. How many rides could someone go on without spending more than $15? Well, $15 is a total amount, that's a y. So I'm going to say 15 is equal to 0.35x plus 8. Subtract 8 from both sides, and I get 7 is equal to 0.35x. Now, I could use a calculator and divide 7 divided by 0.35, or I could say 7 is equal to, that's 350/100ths x, which reduces to 7/20ths x. And if I multiply the left side and the right side by the reciprocal of 7/20ths, which is 20/7, those cancel, and I would get 20 equals x. So he could go on 20 rides. Doesn't ask for a graph, so we'll move on to the next one. This next one's a little more complicated. It says Mrs. Swanson drove 300 miles 1 week in a rental car. The cost of renting the car was $120, which included the weekly rate plus a mileage charge. So this is kind of interesting because she drove 300 miles and the cost was $120. That's really all we need to know. Then another week, she drove 560 miles and the cost was $133. So there's a link between the two of those. If you drive more miles, it's going to cost more money. And it wants to know the charge per mile and the weekly rate, meaning it's the weekly rate, it's not the 120, it's not the 133. It's how much do you cost to charge even if you don't drive any miles. So what we want to do first is we want to set up our let statements. We're going to let y equal the total cost, and then we're going to let x equal the number of miles driven. And if I do that, I actually end up having two ordered pairs. The first one is if I drive 300 miles, it costs $120. And then also we have if I drive 560 miles, it costs $133. So what I'm going to do is I'm actually going to do part B first, because it says write an equation which relates the total cost to the number of miles driven. Well, I know how to write an equation given 2 points, and you should too. I'm going to first calculate a slope, which is 133 minus 120 over 560 minus 300, which gives me a slope of 13 over 260, which reduces to 1 over 20. And then I'm going to plug that into point slope form. We're using one of the points. So y minus 120 equals 1/20th times x minus 300. If I distribute the 120, I get, or the 1/20th, I get 1/20th x minus, and that's 15. 1/20th of 300 is 15. Add 120, and you get y is equal to 1/20th x plus 105. So that's an equation that answers part B. Let's go back to part A and use that equation. The rate in dollars per mile, the rate would be this, because that's the slope, and rate is a slope. So $1 per 20 miles, we could write it like that. So I could say it's $1 per 20 miles, because that's what 1/20th could mean. Or I could reduce 1/20th and say that that's $0.015 per mile, or We could really just say 5 cents per mile. So any of those would work, and they all answer the same question. The weekly cost, meaning the cost no matter what, is the $105. That's the base cost, because that's the cost without any miles. So the weekly cost is $105. So it's pretty expensive for the week, but it's pretty cheap per mile. Finally, it says, let's graph it. Graph the equation, so we're going to graph it. Let's turn the grid on. And it wants to know if it's driven 800 miles in a week. So if it's driven 800 miles in a week, we may have to make our x-axis just be a little bit bigger. What I'm going to do is we're going to make this 100, 200, 300, 400, 500, 600, 700, and 800. And then I'm going to sort of set my 0 at the 105. And we're going to go up and do a t-chart of x, y, 0, 105. I'm going to plug in 100 and just see what happens. 100 times 1/20th is 5, and then 5 plus 105 is 110. And then I'm going to keep going up. 200 becomes 115, and 300 becomes 1/20th, and I should just get it from there. So this is going to be 110, 115, 1/20th, 125, 130, 135, and if I put points all the way out to where I have 800, I should just barely reach it to 140. Oops, I did it again. These have got to slide over here, and I need another point because it was 0, 105. So it's 145. Okay, then we take and connect those. Oops. And if you notice, I did forget to label my axes, so we're going to do that right now. This is number of miles driven, and this is cost in dollars. Another way to do the answer the question C, because it says this is the point we want, 800, 145, which means that it costs $145 to go 800 miles. Another way to do that is actually just to do the equation. Y is equal to 1/20th x plus 105. If I substitute 800 in for x and add, I'm going to get 145, which is what we got right there. And that's it.